What are the key considerations when choosing the operating system of an embedded Linux device? And should you roll your own or rely on a commercial distribution? Let's compare Yocto and Ubuntu Core, the two most popular solutions in industry, to find out. Yocto is a popular open-source collaboration project that helps developers create a custom Linux distro for their embedded applications. Among the go-to platforms in the industry and benefiting from broad Silicon vendor support, Yocto outputs a root file system image, a kernel, a bootloader, and a compatible toolchain for the target device. Yocto is extensively configurable and provides developers with control over every stage of compiling and building the target via recipes, layers, and BSPs. Ubuntu is the de facto Linux standard adopted by millions of users, developers, and manufacturers alike. Recognizing the advent of the Internet of Things, Canonical has created a flavor of Ubuntu with a minimal footprint: Ubuntu Core. Ubuntu Core is Ubuntu for embedded devices. The entire system was redesigned from first boot, so developers don't have to implement complex security features themselves. Ubuntu Core is fully built from snaps, containerized software packages with strict control over permissions and interfaces. There are several dimensions you should pay attention to when choosing an embedded Linux for your device, starting with security. Some basic security solutions are available with Yocto. For example, the Meta Security Layer provides recipes with a few open-source security packages. However, developers are ultimately on their own and responsible for providing and shipping security patches to their Yocto-based images. On the other hand, Ubuntu Core takes a security-first approach, starting with its architecture design. This ensures built-in security throughout the entire application and device lifecycle. At runtime, Ubuntu Core rigidly sandboxes individual applications via a policy-based system that restricts access to the file system, network interfaces, and system calls. The second aspect you should consider is the availability of updates. Yocto has no built-in mechanism for over-the-air updates, and developers need to rely on third-party open-source solutions that integrate with Yocto. Ubuntu Core provides out-of-the-box support for over-the-air, Delta, and Atomic updates with automatic rollbacks. Following changes to the codebase, snaps in Ubuntu Core will calculate the binary delta to minimize the traffic and the time required to distribute the update to your device. Also, Ubuntu Core will not install the transactional updates unless they are 100% successful. The third dimension to look at when choosing the OS of your embedded system is the application ecosystem. Apps are confined with no strict boundaries on Yocto-based devices. Although there is multi-app support, Yocto does not provide an app store, and device manufacturers don't have a direct path toward app monetization. Ubuntu Core, however, is an app-centric operating system. As the intelligence of a device is ultimately a function of the software it runs, a focus of Ubuntu Core is to make every device app-enabled. The device's primary function is an app, and developers can then ship other apps next to that primary function. Also, if you build your device on Ubuntu Core, you can have your own hosted and managed IoT app store, a private application store tailored to software distribution across fleets of devices. Reducing time to market is also critically important. Getting to market fast when working on a Yocto-based image is slow because of its complexity and steep learning curve. Before generating a working image with Yocto, developers must become familiar with recipes, layers, bitbake, and Open Embedded. On the other hand, the combination of Ubuntu Core, its snaps packages, and the App Store offers a ready-to-go solution. In transitioning from Yocto to Ubuntu Core, the time to market becomes much faster, as engineers that used to spend several months developing the entire stack from the ground up can now focus on their value-add software. The fifth dimension to assess when comparing Yocto and Ubuntu Core is the maintenance effort. Developers working on embedded devices running Yocto have to manage their solution, build their OS, maintain their security, and provide updates on their own. Manually maintaining a Yocto-based image is an ongoing activity distracting enterprises from their core business objectives. Companies require substantial expertise and skilled kernel engineers in-house for the maintenance efforts not to turn into a failed product. With an app-centric Ubuntu, however, developers can focus on building apps, as Canonical provides and maintains the low-level components, enabling teams of any size to build highly secure embedded devices quickly and cost-effectively. Kubernetes integration for your device should not be overlooked. Yocto, doesn't provide a built-in Kubernetes integration. Once more, developers are on their own when looking for an orchestration platform. On the other hand, Canonical provides a commercially supported Kubernetes solution for containerized applications. MicroK8s is a lightweight Kubernetes distribution for clouds, workstations, edges, and IoT devices. Combining Ubuntu Core and MicroK8s creates a streamlined, embedded Kubernetes experience optimized for size and performance in IoT and edge applications. Another critical consideration is the availability of commercial support. In a community-driven open-source project, individual maintainers often handle security after the fact. If you have a reputation for reliability and trust, you simply can't afford to be dependent on individual contributors. Challenges not addressed by community-maintained projects are bound to surface when shipping embedded Linux in production. Canonical fills this gap by providing enterprise-grade support, expertise, and a constant stream of security updates to Ubuntu Core devices via a software distribution machinery well-tested in production environments. The final dimension we'll look at is the product roadmap. The contributors of a community-led piece of work may just be solving their specific use case or pain point, and not be interested in the bigger picture and overall system architecture. This leads to legacy layers in Yocto, unmaintained BSPs, and poor testing results in critical vulnerabilities and technical debts. On the other hand, a commercially supported embedded Linux distribution provides stable reliance on a long-term product roadmap. The success of open-source projects or contributions depend on its leadership, usually by the founders, but sometimes in a more institutional way, as is the case with Ubuntu. Let's recap what we learned so far. The inherent flexibility of Yocto provides developers with control over every stage of compiling and building a custom, embedded Linux distro from scratch. Invariably, the extensive configuration options expose significant complexity to the end users. Canonical fills this gap by reducing the risks and uncertainty involved in launching and scaling embedded Linux products, while accelerating time to market. Ubuntu Core is an Ubuntu flavor with a minimal footprint and a simple, stacked architecture. From home control to drones, robots, and industrial systems, Ubuntu Core provides robust security, app stores, and reliable updates for all your IoT devices. Unlike other embedded Linux, Canonical supports devices running Ubuntu Core for up to 10 years, delivering security patches and bug fixes so that your embedded devices are always up to date.